We're going to use the angle, sum, and difference formulas in a different way today. So for example, down here we have find the exact value of the cosine of the quantity x plus y, given that the sine of x is 5/13 and the sine of y is 4/5. Angles x and y are both in quadrant 1. So this makes it easier saying that we're in quadrant 1. We know that all trig functions are positive in quadrant 1. So we don't have to consider the signs of the different trig functions. X and y are different angles. So if we know that the sine of x is 5/13, this is something that we can actually represent with a right triangle. And this is something that we've been doing since the very beginning of this semester. So if we were to draw a right triangle, so here's my right angle, and let's say that x is one of our acute angles, so let's put x here. Then the sine of x being 5/13, we know that sine is opposite over hypotenuse, so that would be 5/13. And we could also represent the sine of y equaling 4/5 with a second triangle. And again, this is going to be a second triangle because this is a different angle. Angle y is not the same necessarily as angle x. We don't know what the values of x and y are, but we do know the sine of each. So the sine of y, if we were to put y here, is going to be 4/5. We know that we're looking for the cosine of x plus y. So the cosine of x plus y, if we use our addition formula or our sum formula for cosine, so that's going to be this formula right here. So the cosine of the quantity x plus y will equal the cosine of each angle multiplied together. So the cosine of x times the cosine of y minus the sine of each angle multiplied together. So that's going to be the sine of x times the sine of y. So we have the cosine of x, we have the sine of x and the sine of y. We need to find the cosine of each. And the only way that we're going to do that is by finding that other side, the other leg of the right triangle, which means that you might need to use the Pythagorean theorem. So for instance, here we could say that a squared plus 5 squared equals 13 squared if we don't know what this side is off the top of our head. So that means a squared plus 25 equals 169. Subtract 25 from both sides, so a squared equals 144, and therefore a equals 12. So this side here is 12. And then over here, if we have one leg is 4 and the hypotenuse is 5, this is actually just a 3, 4, 5 triangle. If you didn't know that, you could just use your Pythagorean theorem to find that as well. So what this is telling us, or this is giving us enough information to get the cosine of x and the cosine of y. So let's fill in then what we know. Therefore, the cosine of x is adjacent over hypotenuse. So that's going to be 12/13 times the cosine of y, which is going to be 3/5, minus the sine of x, we were already told was 5/13, times the sine of y, we were told was 4/5. What's nice about this is following order of operations, I know I'm going to multiply first, but because each of these has a 13 and a 5 in the denominator, they're going to get common denominators, which will make the subtraction easier. So if I do 12 times 3, that's going to be 36/13 times 5 is 65. Minus 5 times 4 is 20/65. So since they have a common denominator, I can take 36 minus 20 to get 16/65. We would want to check with our calculators to make sure if this reduces or not, which it does not, which means this would be our final answer. So the cosine of this angle plus this angle, x plus y, is 16/65. Let's take a look at another. Find the exact value of the sine of a minus b, given that the cosine of a equals 8/17 and the cosine of b is 3/5. So again, we want to draw two right triangles. One that's going to help us with angle A, and then one that's going to help us with angle B. Again, the fact that they're in the first quadrant just lets us know that we're not going to have to worry about, if the tangent, for instance, is positive or negative, if the sine is positive or negative. So if we have angle A over here, we were told that the cosine of A is 8/17. So that means adjacent over hypotenuse. And then angle B over here, we said the cosine of B is 3/5. So again, I can see this is going to be a 3, 4, 5 triangle. If I need to find the missing side over here, I can use Pythagorean theorem. 8 squared plus b squared, if we're saying the side is lowercase b, equals 17 squared. I know that 8 squared is 64. So 64 plus b squared equals 17 squared is 289. So if I subtract 64 from both sides, that means b squared is going to equal 225, and therefore b equals 15. So this side over here is 15. So what's left is to figure out what is the sign of the quantity a minus b. So this is a sine formula, and it's going to be a subtraction, a difference formula. So we're going to use this one down here. So this is equal to the sine of the first angle times the cosine of the second, so times the cosine of b in this case, minus the cosine of the first angle, so a, times the sine of the second. So filling in what we know, the sine of a is opposite over hypotenuse, so that's going to be 15/17 times the cosine of b is 3/5 minus the cosine of a was 8/17 times the sine of b. So the sine of b is opposite over hypotenuse. That's going to be 4/5. Again, we multiply before we subtract. So these are going to have a common denominator. 17 times 5 is 85. 15 times 3 is 45. Minus, over here again, common denominator, 8 times 4 is 32. So now we can subtract these with the common denominator of 85. 45 minus 32 is 13. You always want to double check whether or not that can be simplified. 13 over 85, if you were to type that in your calculator and use the math fraction button, that is as simplified as it can go. So that's going to be your final answer of the sign of a minus b. Let's do one final one using tangent. So we have here alpha and theta. Those are our two angles, the tangent of the quantity alpha minus theta. Given that the cosecant of alpha is 13/5 and the cotangent of theta is 4/3. Again, those angles are in quadrant 1. That helps us out. So let's draw our two triangles, one for each angle, alpha and theta. They're going to be right triangles. And we know enough about cosecant and cotangent to still be able to label these triangles. So let's say that if this is alpha here, then the cosecant of alpha is 13/5. Then that means that the sine of alpha is the reciprocal, 5/13. So that means here is 5 and this is 13. So if we want to solve for that missing side, we can say 5 squared plus x squared equals 13 squared, but I believe we actually already did that, right? 5/13, we knew that the other side was 12. So you could go through and figure out that x equals 12 here, or maybe you're going to start to memorize some of these special right triangles. If this angle here is theta, cotangent of theta is 4/3, then that tells us that the tangent of theta is the reciprocal, 3/4. So opposite over adjacent. So this is a 3, 4, 5 triangle. So we need to figure out the tangent of alpha minus theta. In that case, since it's alpha minus theta, we're going to use this bottom one here. This is going to equal the tangent of the first angle, alpha, minus the tangent of the second angle, theta, divided by 1 plus the product of the tangent of each angle. So the product of tangent of theta times the tangent, or I'm sorry, tangent of alpha times the tangent of theta. So let's fill in what we know. Well, what's nice here is I actually didn't even need that side being given cotangent. I already knew tangent of theta was 3/4. So I actually didn't even need that, but it was easy enough to know. And then over here, the tangent of alpha is going to be opposite over adjacent, so that's going to be 5/12. So let's plug in what we know. So tangent of alpha is 5/12 minus tangent of theta, 3/4, over 1 plus tangent of alpha, again, 5/12, times tangent of theta, 3/4. The biggest thing here is paying attention to order of operations. So we need to make sure that we simplify the numerator and simplify the denominator before we actually divide. So 5/12 minus 3/4, you can think of 3/4 to have a denominator of 12 also. So if we multiply the bottom by 3 and the top by 3, we get 9/12. So 5/12 minus 9/12 is going to give us a negative 4/12, which is the same thing as negative 1/3. So I can replace that with negative 1/3 if we would like as well. Down here, we have 1 plus a product. We need to multiply that first. So 5 times 3 is 15, and 12 times 4 is 48. So if we take 15 over 48 plus 48 over 48, that's going to be 63 over 48. To divide fractions, which again, we know that this is the same thing as negative 1/3, we take negative 1/3 and we multiply by the reciprocal of 63 over 48, which would be 48 over, 63. And then I would just use your calculator to multiply this out and simplify it. And what you're going to end up doing, obviously 48 over 3, that can simplify to 16. So negative 1 times 16 is negative 16 over 63. And that's not going to simplify any further, which means that the tangent of alpha minus theta is negative 16 over 63. And this is possible because remember, alpha and theta are in quadrant 1. But if I were to subtract alpha minus theta, there's a chance that you're not going to land in quadrant 1 for your final answer. So the tangent of that angle, the alpha minus theta, which might not be in quadrant 1, it's okay that that's a negative number because alpha minus theta could put us in this quadrant here, right? It could put us in that fourth quadrant, meaning it would make sense for the tangent there to be negative.